In this lesson, we're going to take a look at using triangle similarity theorems, and we're going to learn a couple more theorems as well. So just to review, we've got three different ways, similarity theorems, that can be used to prove triangles are similar. And that is the angle-angle similarity theorem, the side-side-side similarity theorem, and the side-angle-side. Whenever we have angles, we know that angles need to be congruent. So whenever we're talking if there's an angle in one of these theorems, that has to be a congruent angle. If we're talking about sides, sides have to be proportional. So if we have these two triangles, our side, that means DF over LG, or LJ, is proportional to FE over LK is proportional to KJ over ED. So they'll all have the same ratio. And on side angle side, there are two sides that are proportional and the included angle is congruent. So we need to remember that. So just walking through this, what other information, if we're going to prove DEF and JKL, we need to show that DE over JK is equal to DF over JL. That means that they are proportional. The ratio is the same. And to do it by angle-angle, so that would give us side, angle, side. If we're going to do it by angle, angle, we have D and J already congruent, and we need to either prove that K is congruent to E or L is congruent to F to get two angles. So those are two ways that we can prove those similar. So now we're going to talk about a couple theorems. One is called the side splitter theorem, and then the converse of the side splitter theorem. So if you have a line that is parallel to one side of the triangle and it intersects the sides, so here it intersects here at D and E, then it divides these sides, AD and DE, into proportional, meaning AD over DC is equal to BE over EC. So there is a proportional. So we can use that to set up, if we're missing a length, then we can find the whole length. So when we have a side splitter, if the lines are parallel, wherever this line is, so if we had a line that split the side right here and it was also parallel, then the segments that are created right here would also be proportional to each other. So, and then the converse is if a line divides two sides of the triangle and it's proportional, then it has to be parallel. So it can go both ways. So let's just take a look at this and how we can figure this out. So based on this information, which side length do we need to complete the proportion? So if the side splitter theorem says that if we have two lines that are parallel, JL is parallel to MN, that means JM, this segment right here, over MK, so this is where this line splits JK. So we take the two segments where it splits it, JM over MK, and then we look at this side, the other side where it splits the side. So we have the whole segment LK, but we have LN is what they're giving us, and that is over NK. So that is the side splitter theorem. That proportion is equal. And the way this helps us is it can help us solve proportions when we're given sides like this. So if in this case we have two lines that are parallel, this one cuts the triangle at 2 points, G and H, and we have 4, 11, 2, and we want to know what this HD is. Well, if you'll see right here, it's set up a proportion 4 over 11 equals 2 HD, 2 over HD. So in order to solve that, all we have to do is cross multiply. So that's 22 is equal to 4 HD, divide by 4. So we get HD is equal to 5.5. That's the way it equals. Remember when we cross multiply, another way of looking at this is if we have 4 over 11 equals 2 over HD, we cross multiply and then we divide by the third side. That's exactly what we just did. We cross multiplied, set it equal, and divided by the third side. That's just kind of a little shortcut if you don't want to write out both sides. So let's take a look at this proof. If we're going to do the converse of this, applying the converse, meaning if we know some things, then we know that the lines are parallel. We want to make the lines parallel. So by the converse of the side splitter theorem, if JK over KL is equal to, now we've got to look at the other side. What is the proportion going to be equal to? Well, we want to take NM over ML. That's the proportion that we want to set equal in order to prove that those two lines are parallel. So NM over ML, then those two lines are parallel. And then we can substitute the expressions into the proportions. So we have x minus 5 times x plus 4 is equal to x times x minus 3. So we just cross multiplied. Then we use our distributive property, and we take x times x, x times 4, negative 5 times x, negative 5 times 4. That's what's getting here, and x times, and we're getting this property right here. Now if we just simplify this, we have x squared. 4x minus 5x is a negative 1x, or negative x, minus 5 times 4 is 20, and that equals x squared minus 3x. And then if we write this out and we say, well, x squared minus x minus 20 equals x squared minus 3x. If we're going to subtract x squared from both sides, we get rid of our x squareds. I'm going to add, well, let's see. I'm going to add x to both sides. So that's 0, and I'm left with negative 20 equals a negative 2x. And I divide by negative 2, divide by negative 2, and I get x equals a positive 10. So that is the value of x. And that makes those two lines parallel. Here's another one. A mid-segment, we need to know this terminology. A mid-segment of a triangle connects the midpoints of two sides of a right triangle. So here are the midpoints. We know these are the midpoints because the sides, it splits the side into two congruent pieces. And you'll notice the hash marks here, the 3 and the 2. So these are all midpoints. And if we connect any two midpoints, that is called a midsegment. And you'll notice I actually have 3 midsegments on a triangle because there are 3 sides of a triangle. So we can connect 2 sides and form those midsegments. So if we look at this, if this is a midsegment, if PO is a midsegment of L and M, that means P and O are both midpoints. So I can say that MO equals OL, NP equals PM. So in this case, which one is MO congruent to? Well, MO is congruent to OL. Because if it's a midsegment, then each of those points splits the side that it comes in contact with into 2 congruent parts, because that's the midpoint. And so our triangle here's another theorem. And all these theorems you should probably write in your notes. If you need to rewind the video, pause, take notes on them. There's a lot of them, but they're all connected. So the triangle midsegment theorem says that the midsegment of 2 sides of a triangle is parallel. So this says this is parallel to the third side. So this is the midsegment of AB and AC. This midsegment connects this. We know that these two are parallel, and not only know that we know it is parallel to the third side, but it is also half as long. So we know DE is equal to 1/2 BC. And that's really useful when we're trying to solve for side lengths of a triangle. So let's look at this. If H is the midpoint of GE and J is the midpoint of FE, then we know that HJ is a midsegment. So, and what we know about the midsegment is that it is equal to, so HJ is equal to 1/2 of GF. And now we want to find the following lengths. We want to find HJ and then we want to find JE. Well, let's find HJ first because we need to solve for X. Once we know what X is, then we can just substitute it in and find JE. So I'm going to say HJ is X plus 3, and that is equal to 1/2 of 4X minus 4. Now I'm going to multiply both sides by 2 to get rid of that 1/2. So I have 2x plus 6 equals 4x minus 4. And I'm going to subtract 2x from both sides. So I get 6. Well, let's see. I'm going to actually do, and then I'm going to add 4 to both sides. So that is 0, that's 0. So I have 10 equals 2x. Divide by 2. So x equals 5. Now that's not the question. We want to know what HJ is. So if x equals 5, then we just put in 5 in for x, And so 5 plus 3 equals 8. So hj equals 8. And je, we just put in 5 for this one right here. And 5 minus 1 equals 4. So here, take a pause, write these things down. These are the 3 key theorems that we've talked about. Remember, the side splitter theorem says if we have 2 lines that are parallel, one splits the triangle and it's parallel to the third side, then we know that the segments that it splits into, DE over EA, is proportional to CB over BA. That's the side splitter. The converse says if we have proportional sides, in this case, XR over RQ is equal to YS over SQ, then we know those lines are parallel. And finally, the mid-segment theorem says that if we have midpoints of 2 sides of the triangle and we connect them, that's called the mid-segment. And that we know that that segment and the third side are parallel, and we know that OM is equal to 1/2 of LJ. So we know 2 things from that. So let's do some practice things. So using the side splitter theorem and its converse, the mid-segment, let's answer these questions. Is KM parallel to JN? Why or why not? Well, we need to know if those are parallel, then 10 over 16, this would be the converse, we'd say 10 over 16, is that equal to 15 over 24? If that's true, then this is the way it is. Now, I look over here and I notice I have 16 over 10, so I could rewrite that as 16 over 10 equals 24 over 15. And if we worked that out, this would be 1.6 equals 1.6. So yes, that is true. 16 over 10 equals 24 over 15. So pause the video and see if you can find which statements are correct in this one. All right, in this case, 1/2 of QP is equal to UT. That is true because this is a mid-segment. We also know, but this one, 1/2 of TS is equal to RQ. That's backwards. It should be TS is 1/2 of RQ. So that one's not right. SU is not equal to PR. It should be 1/2. SU is parallel to PR. That is true. We know that those are parallel by the mid-segment theorem. And UT is not perpendicular. Okay, to prove part of the mid-segment theorem, which one must be true? We want to know, in this case, we're looking at all of these things are GH, JK, and JL. We want to show all of these are talking about lengths. The mid-segment theorem doesn't have anything to do with slope, so we don't need to worry about that unless they are parallel lines. But this case, JL and JK are not the lines that are parallel. They are GH and KL. We want them to be equal. The other thing we need to, but we also know that the length of GH is 1/2 of KL. So that's the one that we need to know, that GH is 1/2 the length of KL. Okay, pause the video and see if you can figure this one out. So by what's marked here, we can tell that D is the midpoint of AC because we have these congruency marks. And then we can apply the triangle mid-segment because this is a mid-segment. So we know that ED is 1/2 of BA. And then we just solve x plus 2 is 1/2 of 4x minus 6. We get x equals 5. Now because x equals 5, then BC, right here, this length right here, BC, so x is 5, so BC, 5 plus 5, the whole length is 10. So try this one. Okay, you should have got 9.8, recognizing that MN is a mid-segment, so it's 1/2 of 19.6. This one's asking for the perimeter, so use what you know about mid-segments and see if you can find the perimeter of JKL, which is our large triangle. So pause the video. All right, check your work. You can tell these are all mid-segments, so I can find the lengths of each of those sides and get 19. The other thing you could do is you could take 4 plus 2 is 6, plus 3.5 is 9.5, and that would be 1/2 of the perimeter because that's also proportional. Pause the video and see if you can get this one. All right, if you'll notice, it tells us that A and B are midpoints, so we know that QA is congruent to SA and so forth, so then we know that it is 4 meters. And finally, pause the video and try one last problem. Make sure you read the question carefully. It's asking what is DM. One way you can do that is you can say, well, this is a mid-segment, so it's half of this length, so I can find out the whole length, but then that is half of that, so it's 38. But if you notice that if this is half of the whole length And the midpoint divides it into 2 equals half, so we could just say 38 is equal to 38. So those are the ways we can use the midpoint segment theorem and those triangle similarity theorems in solving for different things.